Okay, welcome to episode 7, Abundance. In this one, I'm going to revisit the Pyrheliometer or hologram burner, solar powered hologram burner that I talked about in a previous episode. This is the device here on the right that I saw in this von Nostrand's magazine from 1888, and this link QR and stuff should take you to this archive.org page. And this is the device here. I just cropped it out, cut it out of there, so I could put it into this horrible graphic. I'm terrible with graphics, but you get the idea. And I'm let's talk about the creation here and how holograms are created. We have just a graphic I got off the interwebs, and so we have our basic holographic creation process. Here's our holographic plate where everything written to. And these reference beams, the coherent beams, here they're showing a single laser, but um, because we need a constant, specific light form that's coherent. And in this case, I believe they're using sunlight. We have three slits here on the Pyrheliometer device. These slits here were for the reference beams to come in. This is a three-dimensional spherical chamber, so they were reflecting off, and reference beams were hitting that central chamber. Uh, that's and then the reference beams, the sunlight going through however this crystal was creating the coherent waveform. I'm not sure. It had to be simple and natural materials, nothing exotic. So the sunlight here are reference beam are coming in reference beams. So I kind of expanded out this the graphic in the way I think it was originally designed to work. Yeah, and that's a piece that in the article they don't talk about at all. They don't talk about the object or the reflectors, like the reflectors in the object. So you can see they don't talk about what is coming into the in here. They talk about sunlight only. Um, so we're using sunlight obviously as a good source of light, and then we can magnify it by heliostats. We can increase the energy of it, and then through the crystal we have the coherent waveform. The object beams are what you get from the reflection of the reference beam. So we're hitting our object here. That's actually an old heliostat. Uh, the object beam, so this is the part I added in here. The object beams, and then they come into our central chamber here. This is, I believe, was the holograph burner chamber. And this device was quite advanced because uh, we had a water cooling system that they only briefly talk about. And then the whole device was extremely solidly built on a substantial table. This central hologram chamber could be evacuated, it could have a vacuum. They had a thermometer in there measuring, they were using, when the sun was out, they got this center chamber up to 600 degrees Fahrenheit. So, and then you had different shades in these movable reflectors, so you could like cut off the light immediately, or uh, yeah, I'm not sure what the whole how the whole system worked, but I'm positive that in here you could create you could burn holographic data onto whatever natural substances that can be done with. And that goes into our, let's see, we have all our antique like heirloom jewelry and stuff. So that's been laying around, in museums and jewelry boxes. And so the other thing with what, as far as I know, is gemstones today, the ones that have more value are the ones that are clear, crystal clear, right? So that they scintillate and sparkle and reflect all this light. But when you burn an image into a crystal, there's some sort it appears as a cloudy like inclusion, and so now those crystals were like, oh, this isn't, these aren't worth anything. They're like all cloudy and have inclusions. So it's probably they could have had holographic data burned on them. And so this is like really, it could be just a smoking gun to discover our old history. We have the idea too, or the throughout our history, the royalty and the special chosen people who elected themselves to rule. You know, they're always wearing jewelry, big pendants, diamond tiaras, and rings, and all this stuff of with massive gemstones, right? Huge. And why the holographic technology? Because it is like the most advanced way to store data. Long term, it's not going to get corrupted. It's burned into a crystal. It doesn't have to be some super high end diamond or expensive rare material. I believe quartzite and other forms of man-made material could do it as well. They had ruby lasers that they were using originally to create holograms, and they were creating man-made rubies uh, through some flame process. I'll show you. Back in the 1800s, they're man-made crystals. So the types of data that could be stored in there, we have the engineering types of schematics, like the uh, the imagery here of this device. Like some of it's extremely detailed and high resolution, right? Now you can burn like a just a 2D like picture into into like as a hologram, but it's the really the 3D aspect that's would be the most uh, uh, powerful, and you get the most bang for your buck that way, right? So when we're looking at all the like a lot of these old magazines and schematics, and we have the engineering that went into so many things. I talked about steam engines in the past, but we had like imagine you have schematics for a steam engine or any type of mechanical engineering design that's I think done in AutoCAD today, right? You had it all encoded three-dimensionally in holograms. Now it's 100% accurately we're going to be able to scale it in a very 100% accurate way without any software through the natural uh, data that's encoded in the hologram, the three-dimensional scalable image, right? So if you have a schematic and you have everything designed out for all the physics and formulas and math for let's say a steam engine that's 1 horsepower, right? Whatever size that is, however it's configured, right? Now your schematics are burned in a hologram and you want to scale it up from 1 horsepower to 50 horsepower. Well, everything would just scale in size until you would scale it to whatever your machinery is set. Like, oh yeah, this machinery we can scale up to, let's say it's pipes, uh, 6 inch diameter, 12-inch diameter, depending, right? So because I don't have it up, but like when I was looking at the steam engines, some of the units were so heavy, and it would never happen today because the cost, right? They would say like, oh well, we don't need this part of the machinery to have all this metal and weight and engineering and cost related to it, right? So we're going to scale that down or cheapen it up, to save us money. But that's not the way they used to do it. Now, that's why so many in the descriptions of the old steam engines, they were just off the chart in the engineering and the weight because they started with a design and it just scaled up. So if if I started with this design and it was like 1 horsepower, if I could scale it up, there would be nothing. There's none of this fiddling and tweaking and shaving and cutting costs because you're just like that's now it'll work as long as the mathematics of everything that was solid from your original design, you probably hit some limits depending on the physics and the mechanical engineering and stuff, but you could say like, yeah, this we can scale this up to 500 horsepower, 1,000 horsepower, but no, we can't go further because we're going to hit a limit on this device. And they're like, well, it's not worth it. Just you start with the scalable three-dimensional model. It sounds so like crazy, right? Because like to think that they were doing this advanced stuff 100, 200 plus years ago. They were, because this, but so we have this device here with the receiving the object beams or reference beams, being able to burn this data into crystals. Um, and this could have been used for transmission of holographic data as well. So I don't know. I don't, because they don't really describe everything that's connected past through back through this chamber. The holographic burning chamber had a long cylinder tube, and they had, when they were testing it, they were supposedly using mercury, and it had a thermometer. But it doesn't. They don't really talk about anything else created back here. Now, when I say transmission, there is a precedence for this. We had this device from Alexander Graham Bell, the photophone, which so this is using light beams to transmit audio communication, speech. He's in big on description, and they could actually. This was actually a dialer because they had multiple pencil beams of light that could have been sent or that were sent and then received, and you could like select here which one you want to like decode. And they had an audio channel and then a video channel, or I don't know what they had, but like, why send all these multiple beams? Because if whoops if you have using the sunlight as your reference beam, it, you can disconnect what they have as the whoops what they show today as just using a single laser. It can all be separated out because we're using the sunlight, which is like our common, great, amazing light source. Okay, so the we can find our lost history is in plain sight. I have no doubt. I mean, the we had the antique. Oh, these are the gemstones. Now, like talking about, oh, how today like clear gemstones that don't have inclusions or cloudiness are valuable. I mean, we have the royalty and the elite with all their jewelry, right, in plain sight type of thing. And but we had the idea too of like, oh, my grandmother is passing down this pendant or something from our family, and I have no doubt that there is jewelry, pendants, whatever, has like photo, like holographic photos and burned in them of like family photos that could be going back hundreds and hundreds of years. It's all been buried and lost. We This was all by design to lose this technology. Um, Let me find this one section here. I gotta find this where he talks about why why he goes through all this experimentation with this device and then it doesn't go anywhere else. You've never seen or heard anything about this thing. Like that we were able to burn holograms into crystals. Oh, here it was. Yeah. It should be mentioned that the trial of this new Pyrheliometer has not been concluded, owing to the very unfavorable atmospheric conditions since its completion. So, like, oh, he's using in the article, he's trying to measure the temperature of the moon with this Pyrheliometer, and he's just getting the from what I remember, he's just got the temperature of like the ambient air because the moon isn't producing any heat. But and so uh, you could also think like, oh, he's not. There's just too many cloudy days, and he's not able to really test this out and experiment on it too much. And it's no, this device was shut down. The unfavorable atmospheric conditions is the temperature of the room he's going back to report on. All of the so much of everything's been stolen from us by I don't know who the groups are. Their time is running out. Okay, so you get the idea. I think on that a bit more on the Pyrheliometer. I hope this graphic kind of helps. It's horrible. I'm terrible, but you kind of again you can see how I connected this, and in the discussion of the photo phone here, he mentions talking going long distances. So this could have been some sort of receiver, or it doesn't matter, but absolutely positive. It makes sense. It's all in plain sight. It's all been like hidden from us by clowns that have been writing history. They've been taking our real history and just been hacking it up to fit and hiding so much, burying it, right? Because anyway, because now, like, when people are like, oh, holograms, it's all the modern poison freaking substances that are used. It's all garbage. So, like, you have this crystal. Imagine it's just like a quartzite. It doesn't have to be a diamond, but it's got the holographic data burn. Say it has the engineering schematics or something like that. You could take, say it's something you can shatter, and I could just shatter it into a million pieces. I could take it just a tiny shard of that, and as long as the I could get the small enough reference beam hitting it at the right angle and everything, I'm going to be able to recover all of the holographic data that was burned on there. So you want to talk about like data integrity, data redundancy? I mean, of course, holographic data stored in crystals would be the way to go. It's the most advanced, and that's what they had because they were so advanced. The stuff we have today is all garbage. Yeah, I know I'm using a computer. What else? We don't have any. I don't have something else right now. So that's all I'm going to, I guess, talk about in this episode because I want to do this horrible graphic just to kind of so you can visualize and see like, oh, you can look at all the different ways they're creating holograms, and it all fits with this. It all you can map it all into what they were showing in this device. So that's all for now. Uh, I'm going to be working on getting setting up not hologram, helio heliostats at some point here. There's so much, man. And then once you have the heliostats, like figuring out just getting the reference beam, it can't be too difficult. And then you could theoretically start like, oh, let's see if we can find some ho- holographic data on old crystals. Because now, if you had holographic data on a crystal and it used some sort of weird laser wavelength, right? You'd have to like experiment and find that wavelength to recreate it. Maybe there's some way you could decipher it quickly, but from the crystal structure or from the it's sapphire or it's ruby or diamond, that type of thing. But 100% it was sunlight, so we don't there's not like, oh, what wavelength were they using. It was the simplest thing to create the coherent waveform there. Now the other thing I want to talk about leading into the next episode, where I'll talk about oxyhydrogen flames, was because it does relate into this when we're talking about they had man-made crystal. There's a flame fusion process that was created back in the 1800s to you basically have like a fine powder of the right elements, and you're hitting it with a oxyhydrogen flame, to to fuse everything together. And this guy Bernoulli, he created the first synthetic man-made ruby crystals back in the 1800s. And then we had ruby lasers that were used in the early days of holography. I'm sure they're still around. So what I'm getting at on this is like this guy, let's see, the Bernoulli method. He was a French chemist, 1883. This guy, Auguste Bernoulli. Bella, molto belle. I have this weird thing where every time I something oh, that's French, not Italian. Well, anytime I think I hear something French, I think I got it from that movie Amadeus. I think bella, molto bella. Beautiful, very beautiful, like a sapphire or a ruby. So just hilarious to me. But the guy uh, having oxyhydrogen available and whatever this device is that he found, he didn't build this. Same with the oxyhydrogen. They had all this material there and they were just freaking playing around with it. Yeah, let's just fuse some let's just make some rubies today, huh, Bob? Like, okay, like you got all this stuff laying around to do that. Yeah, because it was left over from the previous world, the Great Reset, whatever happened. I don't want to think about it because it's so horrifying what we've lost. And so the oxyhydrogen flame, I'll talk about this next because I'm positive we had lots of electricity from the steam engine tech. And so electrolysis to split water into hydrogen and oxygen gases. And then you burn the oxygen hydrogen flame, burns super clean. And oh, I thought it said it here. Oh, here it is. Oh, this was sapphire. So even today, we're creating man-made sapphires, laboratory grown sapphire crystal, and this is like designed for wafers. That's why it's got lines. So uh, it's not designed to be like extremely solid in its form because of the way it's precipitated or something grown. So I mean, we have this ability. Yeah, it requires a lot of heat, and we have pressure. We have all the stuff down in the earth that supposedly that creates all kinds of different gemstones, metamorphic things like marble is a metamorphic form of limestone, I believe. Uh, and so all of this stuff in the earth, it's a geothermal heat and pressure, or hydrothermal heat, pressure, and water. And the pressure could be, we might be talking about negative pressure, vacuum in some of these cases as well. And same thing like diamonds, right? They say, like, oh, Superman, a thing of coal, he could, with enough pressure, geothermal, or just pressure, he could squeeze it into a diamond, right? And sapphire is uh, very valuable and powerful or useful in the industry because of, well, the crystal structure, but it's very hard. It's like a 9 on the scale. Oh, yeah, the other thing here. So you guys remember from Star Trek 4, where they're going to save the whales. They go back in time and they're like, hey, we need to put the whales, we need to have a containment for the whales. And Scotty and them go to a factory and give the guy a formula for what? Transparent aluminum, because that's hard enough. And the weight and everything, the whales will be safe in their pools, transparent aluminum sided pools in the ship, right? Well, what? And if you look up, they people turbo nerds have done all these like formulas. Like, what is the transparent aluminum? Yeah, it's right here. It's sapphire, aluminum, and oxygen is sapphire. That's transparent aluminum because there's, well, here the ampule thing here that they were creating. This is clear sapphire. That's transparent aluminum. It's all in plain sight. It's hilarious. So yeah, we were able to create transparent aluminum, and we had these fusion grown flame fusion rubies. So we could have like created the crystals that then were burned as holograms, because there's also the quartzite, which is a crystal form of glass. Like, you drink out of a crystal glass, that type of crystal, that that I believe is would work for holograms. I don't know. Anyway, that's all for now. I mean, you kind of get the idea. I have no doubt we can find our lost history. We can find something that is a smoking gun, like mother effers. Everything we've been taught is a lie, and this would be like absolute proof. Like, no, like, oh, it's you could argue, like, if you just found one or something, like, oh, this is like a hoax, it has to be. But no, it's they they're they are probably everywhere, and that would be like just so, gosh, yeah. I mean, people need to wake up. Like, all of our history is such a lie. Well, because the idea, like, the trust is gone. If you say, like, "Oh, no, no, it can't be a lie," you're making a call to authority. Because you're saying, "Oh no, we should trust these people that like things that were written down and published and edited and redacted and uh, you know, however presented out and published out. Oh, they're great scientists and that and that. What, the same ones that are on the Epstein list today? Exactly. The trust is gone. It's over. Like, you know, every one of these guys here in on all these sites, oh, these great scientists, they're all like the Wizard of Oz characters to me. Once you pull back the curtain, it's just some clown who was turning the dials and pulling the levers and got things to happen, and and somehow they're the great heroes. Okay, they're not. And this idea that, oh, you have to go, oh, I have to become a geochemist or go into chemistry, inorganic chemistry, or whatever, physics, whatever, in the relation of being an expert or being able to, like, recover a hologram off of a gemstone. Now, that's all set to, like, that's all a scam. Like, that curtain in the Wizard of Oz palace, it there's just everything you look at today in our world. It's just imagine there's a curtain there. You just got to keep, and you'll behind it you'll see some clown pulling levers and turning dials like this, and telling you a story. So this, if we could find actual holograms, that's irrefutable. It's hard coded, hard burned, that it can't be like edited and reprinted. So that's why they had to get rid of it so much. All right, all for now. Next time, oxyhydrogen, because so cool what everything that can be done with those two gases. Anyway, all for now. Later. Wrong one.